In 1940, if you walked into an American bowling alley, you weren't just looking at a sport. You were looking at one of the most dangerous, chaotic, and exploitative labor operations in American entertainment. Hidden behind the lanes stood thousands of young boys, some barely into their teens, working long shifts in near-pitch darkness, dodging 16-pound wooden missiles fired at close range, clearing debris by hand, resetting the pins over and over for a few cents a game. No protection. No real bargaining power. No way out except finding a different alley that treated you slightly less badly. They were called pin boys. And for almost 100 years, they were the invisible labor force that made bowling possible. Then, in a converted turkey shed on a farm outside Buffalo, a technician named Fred Schmidt started building a 2-ton mechanical monster, nearly 5,000 moving parts, dime store lampshades, and cone-shaped graveyard flower vases. That ugly little machine would end the pin boys' job for an entire industry, kick off a corporate rivalry that lasted decades, and accidentally manufacture one of the biggest leisure booms in American history. This is the story of the automatic pinsetter and the Industrial Revolution nobody remembers happening in a bowling alley. To understand why this machine mattered, you have to understand the job it replaced. Bowling alleys in the early 20th century ran on a simple, brutal economic loop. A bowler rolled his frame. Somewhere in the gloom behind the pins, a boy jumped down into the pit, cleared the fallen pins, hand-set the next rack into wooden spots on the floor, and shoved the ball back down a wooden rail fast, because the next bowler was already waiting, and the boys' pay usually scaled with how many games got played per hour. Pin boys were often recruited from the poorest corners of American cities, from orphanages, from tenement blocks, sometimes literally off the street. Wages were a handful of cents per game, occasionally topped up with tips. It was, by any account, dangerous work. Fingers got smashed. Ribs got cracked by mistimed throws. Some bowlers, for entertainment, would fire the ball early just to see the boys scramble. And unlike the factory workers of the same era, these kids had no union, no shop floor solidarity, no leverage. High turnover was constant. A boy who got hurt or aged out or just quit was instantly replaceable, which is exactly why alley owners had so little incentive to make the job safer. Child labor laws started tightening in the early 1900s. New York codified restrictions in 1913, but bowling alleys became a well-known loophole. Kids lied about their age. Owners looked the other way. The Children's Bureau in Washington was still investigating child labor conditions specifically in bowling alleys as late as the 1940s. It was, in other words, a labor problem hiding in plain sight inside one of America's most popular pastimes. And it had been unsolved for decades, not because nobody wanted to fix it, but because nobody could build a machine dexterous enough to do a job that required, essentially, a small human being with fast reflexes. Enter Fred, properly Gottfried Schmidt. Schmidt was an engineer, and he bowled regularly at a New York alley owned by a man named George Bickerel. Bickerel had been dreaming for years about a machine that could do the pin boy's job. He mentioned the idea to Schmidt one night. Schmidt happened to work across the street at a factory that built paper folding machinery, equipment that used suction to grab and move sheets of paper. That was the spark. If suction could lift paper, could it lift bowling pins? Schmidt teamed up with a machinist named Fred Sandhage, and together with a draftsman named John McElroy, they started building a prototype. Not in a lab, not in a factory, in a repurposed turkey house on Sandhage's farm. The materials were, frankly, absurd for what they were trying to accomplish. Cheap tin lampshades, cone-shaped graveyard flower vases, the kind you'd see holding fake flowers on a grave. Suction tubing. They nicknamed a resulting contraption the SCH Beckroy, Schmidt, Bickerel, McElroy, all mashed together. It was crude. It was enormous. It barely worked. And Schmidt, understandably proud of it, took it to the biggest name in the bowling equipment business at the time, the Brunswick Corporation. Brunswick turned him down flat, which is the kind of decision that looks catastrophic in hindsight because one of Brunswick's own employees later left the company, joined a much smaller industrial outfit called American Machine and Foundry, AMF, and mentioned, almost as an aside, that there was this odd suction pinsetter project floating around looking for a home. AMF picked it up. In 1941, they bought Schmidt's patent outright. And then World War II happened. Every American manufacturer with heavy engineering capability got pulled into war production between 1941 and 1945, and AMF was no exception. The pinsetter program went into deep freeze. Whatever momentum Schmidt's invention had built up simply stopped. It picked back up in 1944, as the war was winding down, when AMF converted part of a bakery equipment plant near Buffalo into a dedicated pinsetter production facility. That detail alone tells you something about how the story of automation actually works. It's rarely a straight line from garage to global industry. It's stop, start, war, funding, a random hallway conversation at the right company. The automatic pinsetter took roughly a decade to go from turkey shed prototype to public debut, and it very nearly didn't happen at all. In 1946, in a rented garage across the street from a bowling tournament in Buffalo, New York, AMF wheeled out two machines. Each one stood over 7 feet tall. Each one weighed more than 2 tons. Each one contained close to 5,000 moving parts. They called it the pendulator. And when tournament bowlers wandered over to see what the fuss was about, they were watching, without fully realizing it, the beginning of the end for one of the oldest child labor jobs in American entertainment. But here's the part almost nobody tells you. This first machine was genuinely kind of a disaster. The 1946 pendulator used a rotating turntable and vacuum suction to lift and reposition pins, basically a scaled-up, industrialized version of Schmidt's original turkey house design. It looked incredible in a newsreel. Columbia Pictures even filmed a theatrical short about it, narrated by the broadcaster Bill Stern. But in the real world of continuous nightly league play, it kept breaking. Reports from the era suggest each unit needed several technicians making constant adjustments just to keep functioning through a single evening. The suction system, so elegant on paper, was mechanically fragile in daily use. By mid-1947, AMF quietly admitted the design wasn't going to scale. Engineering trade press at the time described the company going back to the drawing board. A new mechanical lifting system, dropping the suction approach almost entirely, was developed through 1948 and 1949, with contributions from engineers including Sanders Fry, and later Thomas Flint and John Fluke, who patented further refinements. It took until 1952, 6 years after that first Buffalo demonstration, for AMF to reach full-scale, reliable production with what became known as the Model 82 to 30 pins potter. That machine, in modified form, stayed in common use for decades. Some of its core mechanical principles are still recognizable in pinsetters running today. This is the unglamorous truth buried under most great invention stories. The demo isn't the product. Getting a machine to work once for a camera is a completely different problem from getting it to survive 8 hours of teenage bowling league chaos 5 nights a week for years. That gap took AMF 6 more years and multiple engineering teams to close. Remember Brunswick, the company that turned Schmidt down flat in the 1930s? By the early 1950s, Brunswick was watching a smaller rival threaten to eat its entire market, and it wasn't about to sit still. Brunswick had its own in-house engineers, including Ernest Hedenskog, working on competing pinsetter designs, and by the mid-1950s Brunswick had its own automatic pinsetter on the market, competing directly against AMF's machine lane for lane. This is the part of the story that turns a single invention into an actual industrial revolution. One clever machine is a novelty. 2 competing manufacturers racing to install that machine in every bowling alley in the country. That's an industry transformation. AMF and Brunswick spent the better part of the next 2 decades locked in a rivalry that would come to define almost the entire bowling equipment business in North America. Here's where the economics get interesting. Before automation, a bowling alley's capacity was capped by how many pin boys you could hire, supervise, and paper shift, and pin boys, being teenagers working nights for cents per game, were notoriously unreliable. High turnover, absenteeism, and slow pin resetting all limited how many games a lane could realistically host in an evening. Automatic pin setters didn't just remove a labor cost. They removed a labor bottleneck. Lanes could run faster, later, and more predictably. A single mechanic could now oversee dozens of lanes instead of an alley needing 1 boy per lane per shift. That efficiency gain landed at exactly the right cultural moment. The post-war suburban boom, rising disposable income, a generation of returning veterans and young families looking for affordable, indoor, all-weather entertainment. Bowling alleys multiplied rapidly through the 1950s and into the 1960s. League bowling became a genuine national institution. Televised bowling shows drew huge audiences. Sleek, brightly lit bowling palaces became a defining piece of American suburban architecture, on the same cultural shelf as the drive-in and the shopping mall. None of that happens at the same speed, Maybe none of it happens at all without a 2-ton suction machine that started life in a turkey shed. But there's a version of this story that gets skipped in almost every cool vintage machine retrospective, and it's worth sitting with for a second. Automation didn't create the pin boy problem. Automation solved it, but only after decades in which reformers, labor advocates, and the U.S. Children's Bureau had been documenting injuries, exploitation, and evaded child labor laws in bowling alleys, without much changing on the ground. The job persisted not because nobody cared, but because there was no economically viable alternative to a kid's hands and reflexes, until suddenly there was. That's a pattern worth noticing far outside of bowling. A dangerous, low-status, badly paid job can survive public criticism for generations. What actually ends it, more often than moral pressure, is a machine that makes the job unnecessary. The automatic pinsetter is a small, strange, almost comic case study, but it's also a preview of a pattern that would repeat again and again in factories, warehouses, and now in offices for the rest of the 20th century and into ours. By the mid-1950s, a job that had employed tens of thousands of American kids for 100 years was functionally gone. A handful of nostalgic holdouts, like Milwaukee's Holler House, still hand-setting pins over a century after opening, kept the old system alive as a novelty. Everywhere else, the pit went quiet, and a mechanic's workshop next to Lane 1 took its place. Next time you're at a bowling alley and you watch that mechanical arm sweep the deadwood and drop a fresh rack in under 30 seconds, you're watching the end point of a 20-year engineering fight that started with lampshades, flower vases, and a farmer's old turkey shed. It's not a story about a light bulb moment. It's a story about a decade of failure, a World War interruption, a corporate rival's mistake, 6 more years of a machine that barely worked, and underneath all of it, 100 years of kids doing a job that nobody was proud of, and everybody quietly accepted, until a machine finally made it unnecessary. That's the forgotten industrial revolution of the bowling alley.